Hi class, as promised on Thursday, I'm going to go over some problems that were not on my practice problem set. So the first one will be this problem here, number 26. I'm also going to go over the worksheet problems as well. So it asks how many grams of methanol must be added to water to prepare 150 milliliters of solution that is 2 molar in ethanol. So we know that molarity is equal to the moles of solute over liters of solution. So what we need to do here is solve for the number of moles. So the number of moles is going to be the molarity times the volume in liters. So we have 150 milliliters of solution. So we go ahead and convert that to liters, and we have a 2 molar solution. So that'd be 2 molar, which is moles per liter, times 0.150 liters. And we'll put that into the calculator, and that's 2 times 0.15, and that'd be 0.3 moles, so 0.3 moles. So now we need to calculate the molar mass of the methanol so we can convert moles to grams. So we have 1 carbon, and that's 12.011 grams per mole. We have 4 hydrogens, so that'd be 4 times 1.00794 grams per mole. And we have 1 oxygen, which is 15.9994 grams per mole. Let me erase this. And this would be equal to, let's see, 4 times 1.00794 plus 15.9994, and I get 32.004 grams per mole. So that's the molar mass of the methanol. So now what I do is I take the 0.3 moles and I multiply that by the molar mass. So 32.04 grams per mole. The moles cancel, and we end up with 9.6 grams of methanol. So let's see. Another one that wasn't on the list was number 28. So the molarity of a solution prepared by diluting 43.72 milliliters of 1.005 molar aqueous potassium chromate to 500 milliliters is what? Well, what we need to use here is our dilution formula. M1V1 is equal to M2V2. So our more concentrated solution, the M1, is 1.005 molar, and we're going to use 43.72 milliliters of the 1.005 molar solution and dilute that to 500 milliliters. So we need to know the M2. So I'll go ahead and solve this for M2. So M2 is M1 V1 over V2. So it's going to be M1 is 1.005 molar times 43.72 milliliters, all divided by 500 milliliters. Milliliters cancel out. We're left in molarity. And let's put this into my calculator. Times 43.72 divided by 500. And I get 0.0879. 0.0879 molar. So right there is the answer for that one. Okay, number 31, the molarity of an aqueous solution containing 22.5 grams of sucrose in 35.5 milliliters of solution is what? So what we need to do is convert the grams of sucrose, because remember, molarity is the moles of solute over liters of solution. So the 35.5 milliliters is the same as 0.0355 liters. And then the molar mass of the sucrose is, we have 12 carbons, so that's going to be 12 times 12.011 grams per mole. We have 22 hydrogens. Each one is 1.00794 grams per mole. And we have 11 oxygens. Wow. Plus 11 times 15.9994 grams per mole. So we put this into our calculator, 12 times 12.011 plus 22 times 1.00794 plus 11 times 15.9994. And the sucrose has a molar mass of 342.3 grams per mole. So we want to know the molarity. So the molarity, well, first we have to find the moles of sucrose. So that'd be 22.5 grams of sucrose, and we'll go ahead and divide that by the molar mass. And 22.5 divided by that is 0.0657 moles of sucrose. So now we just go ahead, and our molarity is 0.0657 moles of sucrose divided by 0.0355 liters of solution, and that should be 0.0657 divided by 0.0355, and I get 1.85 molar. 1.85 molar. And so if we look over here, B is the correct answer. Okay. And then I thought we did this one here, but I'm not sure, so I'll go ahead and redo it. So we're looking at the molecule here, and we're asked to determine the molecular geometry at each of the three labeled atoms. So this is carbon 1, carbon 2, and nitrogen is 3. So this carbon here has three bonds, 0 lone pairs. So this carbon number 1 would be trigonal planar. So let me go ahead and write that, trigonal planar. And carbon number 2 has 1, 2, 3, 4 charge clouds, 0 lone pairs. There are 4 bonds, and so that would be tetrahedral. And then here, the nitrogen has 4 charge clouds, 1, 2, 3, and 4, but one of them is a lone pair. So that's going to give us a trigonal pyramidal molecular geometry. So we have trigonal planar, tetrahedral, and trigonal pyramidal. So the answer here is C. And I don't think we did these two questions here. So the net ionic equation for the reaction between aqueous sulfuric acid and aqueous sodium hydroxide is what? Well, first thing you ask, is it a strong acid, weak acid? Do we have a strong base or a weak base? The acid is a strong acid, the base is a strong base, so therefore our net ionic equation, for any strong acid or any strong base, is this one here. Okay, so that would be this one. If you use hydronium ion, then it would look like this: hydronium ion plus hydroxide ion to give 2 molecules of water. Okay, so either one of these is fine. Here they want to know the net ionic equation for the reaction between aqueous hydrocyanic acid and aqueous sodium hydroxide. Hydrocyanic acid is a weak acid, so we go ahead and let's just go ahead and write the equation. Hydrocyanic acid, we have sodium hydroxide, it's a strong base, and we replace the hydrogen here with sodium, so we have sodium cyanide, and then we replace the sodium here with hydrogen, and we have water. So our net ionic equation then, this does not completely dissociate, so I have to keep it in the equation as is. Sodium hydroxide does dissociate. And we look at our solubility rules, we see that sodium cyanide is soluble. Any compound that contains sodium is going to be soluble. So this will also be dissociated in solution, plus the cyanide ion, plus the liquid water. We see that the sodium ions cancel, so our net ionic equation is so this is our net ionic equation, so we just try to match it to one of these, and it looks like the answer here is E. Okay, so that takes care of the problems that I'm pretty sure that's all of them that that weren't on my list during Thursday's lecture. And you can watch the video from Thursday's lecture to see these problems. So yeah, I think that was it on here. Okay, all right, so I think what we'll do now is we'll go to the worksheet. So here is worksheet 2, and let's see what we have here. Okay, actually what I'm going to do is I'm going to exit out of this video. I'll just post 2 videos, and we'll go to the worksheet in the second video. So everybody have a good evening, and if you have any questions over the exam material, then just let me know. Okay, email me, stop by office hours on Monday and Tuesday. But if you have any questions, please let me know. Everybody have a nice weekend.